Hey everyone, my name is Shashank Shekhar, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for JEE Advanced 2018, Paper 2. For this video, let's have a look at the problem. The question is related to coordinate geometry, right? It involves circle, parabola, as well as later you will see that ellipse also. So the mixed problem of these three chapters. So it requires all the concepts related to all these three chapters. Let's see how can we solve it, however, in easier manner. So question is not difficult, and again you will find as when we go to the option now. So they are also asking about area of the region, so it requires integration also. So it's a multi-concept problem. Let's see. Question is, consider two straight lines, each of which is tangent to both the circle x square plus y square is equal to half and the parabola y square is equal to 4x. Okay, the two curves, however, is given as standard curves, so it's not difficult to deal with these curves, standard curves. Let these lines intersect at point Q. Consider, means the point Q is a point of intersection of the common tangents, the two common tangents of the two curves given, circle and parabola. Consider the ellipse whose center, now they are asking about some third curve, ellipse whose center is at origin, again standard ellipse, it looks like a standard ellipse, and the major axis is OQ, right, and the length of minor axis of the ellipse is given as √2. Semi-major axis is OQ, so we have to find major axis or semi-major axis length. Minor axis length of the ellipse is √2, means its semi-minor axis is 1 upon, means √2 by 2, that is 1 upon 2. Which of the following statement is oblique or are true, means there may be more than one option correct. In option A, for the ellipse, the eccentricity, they are asking about eccentricity 1 by √2 and the length of latus rectum is 1. Option B, for the ellipse, the eccentricity same thing is asked, but with different figures. Option C, the area of the region bounded by the ellipse, first we have to find the ellipse now, between the lines x equal to 1 by √2 and x equal to 1 is 1 upon 4 √2 times pi minus 2, and the area of the region bounded by x equal to, same thing is asked in option D also with different figure, different answer. So exactly out of A and B, maximum one can be true, out of C and D, maximum one can be true. Right, so let's see how can we solve it easily. See, first of all we should plot these basic curves roughly. I'm going to plot it, say like circle, standard one, and the parabola. From the symmetry it is very clear that they will meet on x-axis, however, but okay, take any one of the tangent, common tangent of these two curves. Right, so we know that the equation of tangent of slope m to the parabola is y is equal to mx plus a by m. So we can assume, let the common tangent be of slope m, mx plus, and here obviously a is 1, for ax, a is 1, so a by m, that is 1 by m, is very standardly known, and as it is also tangent to the circle, so distance, applying the condition of tangency with respect to circle, distance of the line from the center of the circle must be equal to radius of the circle, and radius is given, radius is half, 1 by √2, radius is 1 by √2, so it must be 1 by √2. So distance of this line from the center 0 0. So what is distance of this line from the center? Mod c 0 0 say mod c upon under root 1 plus ms square, and that is given to be 1 by √2, must be 1 by √2. So if you solve it, if you square both the sides and getting it, so m square into 1 plus ms square will get as 2, and as m square is positive, so you'll get two values of m from here, however, um, but those two values of one value would be negative, so m square here would be 1, other will be -2, which is not possible because m square is positive. So here the values of m are plus minus 1. We got the two tangents. The two common tangents are when you put these values of m in this equation now, you'll get the two common tangents. Y is equal to x, m is 1 plus 1, and y is equal to minus x when m is minus 1. So obviously the point Q is the point of intersection of these two lines, and obviously when you solve these two lines now, suppose I'm just subtracting these two, you'll get x as -1, y as 0. So -1 comma 0 is the point Q. Point Q must be -1 comma 0, right? So they are meeting in the figure. If we draw it further now, somewhat like this. So this is point Q and this should be -1 comma 0. Obviously it means point Q is -1 comma 0, right? Now proceeding with the question further. So length of semi-major axis is OQ, means finally if we talk about ellipse, the length of minor axis is √2. OQ is coming here as -1. So semi-major axis is OQ now. So semi-major axis with respect to ellipse is OQ, and OQ was coming to be 1. So you can say, and semi-minor axis we can say A is 1, and minor axis length was given to be, it was √2. So we can say B is the semi-minor axis, that is √2/2, that is 1/√2. If we find the eccentricity, we know A square E square is equal to A square minus B square. Now A is 1, so E square is 1 minus 1/2, B square is 1/2. So eccentricity of the ellipse is 1/√2. The latus rectum, if you talk about latus rectum, that must be twice of B square by A. We know the formula, 2 into 1/2 divided by 1, that is 1. So finally if we go to the option A or B, eccentricity is 1/√2 and say latus rectum is 1. If you look at the option, eccentricity 1/√2, length of latus rectum is option A must be correct, B is wrong. Coming to the option C or D, area bounded by area of the region bounded by ellipse between the line x equal to 1/2 and x equal to 1 is okay. So 1/√2 and 1. If I write the equation of ellipse would be x square by A square, that is 1, plus y square by B square, that is 1/2, is equal to 1. Now if you find the area now, so if I plot it, we should show the area which is required to be found. So it is like x equal to 1/√2, x equal to 1. So we have to find this area, and equation of ellipse was x square plus y square by 2 is equal to y square by half, I think, yeah, is equal to 1. So area obviously from the symmetry is twice of area falling in the first quadrant, that is 1/√2 area under the curve, then y dx. And what is y? Y is in fact 1/√2 times under root 1 minus x square. You can easily C, and if you integrate, so root 2 times integration of under root 1 minus x squared dx from 1 by root 2 to 1, and we know the integration, which is very standard. It is x under root 1 minus x square by 2 plus a square by 2, that is 1 by 2 sine inverse of x, and when you carry the limit as 1 by root 2 and 1, so area required is, when you put x equal to 1 here, so first part is 0 and second part is sine inverse 1 is pi by 2 is pi by 4, and minus with minus sign, the first when we put x equal to 1 by root 2, you will get 1 by root 2 into under root of 1 minus 1 by 2, that is 1 by root 2 again, so 1 by 2 1 by root 2 into 1 by root 2, 1 by 2 is 1 by 4, plus just simplify it, and when x is 1 by root 2, sine inverse 1 by root 2 is pi by 4, so we are getting pi by 8 over here. Finally pi by 4 minus pi by 8 is pi by 8, pi by 8 minus root 2 times pi by 8 minus 1 by 4, so finally we are getting it as pi minus 2 divided by what, 8 into root 2, so 4 root 2 finally. This is these square units. So final answer is pi minus 2 by 4 root 2. If you go to the option pi minus 2 by 4 root 2, which is given in option number C, so option C is correct, obviously D is not correct. So answer are A and C, as you can see. Okay, I hope you understood it. So I tried to explain it in very easier manner. So okay, stay tuned for the next question. Thank you so much.